In our previous video, we started this question up to the point where we calculated the composition de l'accélération. And then we shouldn't forget the goal of this question is to find out if it's uniformément accéléré. So that's this. So to prove that it's uniformément accéléré, that it has to be accelerate, it has to be positive, it has to be greater than 0. So there are two ways to find that. The first method is deriving the module of our vector vitesse. I remember, let me bring this back for us to see. When we calculated the module of our vector vitesse, we found that it was 2t. So the two ways to calculate, the first one which we are going to calculate, we are going to start by deriving. And so we are going to have dv over dt, which was a component, so it was this, right? And then we're deriving 2t prime, and the derivative of 2t prime is 2, so it's 2 meters per second square. Okay, so it's 2 meters per second square, which is greater than 0 because we are going for acceleration. So it's 2t prime, which is 2 meters per second, and it's greater than 0. And because it is greater than 0, the derivative of the module is greater than 0, so it's uniformément accéléré. The second method, this one is actually simple also, but the other one you can also apply it. The second method is using the a for v in vector. That's the vector acceleration multiplied by the vector, like the vector vitesse. That's the velocity vector and the acceleration vector, and this is equal to ax, okay, vx plus ay vy. So remember, we calculated our ax and we calculated our ay. So all we have to do is to replace our ax, multiply it by what we got for our vx, which is this. Then we do for ay and multiply by vy, and then see whether we'll get something greater than 0. So that's what we're going to do now. So our ax is negative 2 sinus t square minus 4t square cosinus t square, which we already calculated in the previous video. And then our vx, which we also calculated, was 2t sinus t square. Okay, and then we're adding it to ay, and our ay, in the previous video also we got 2 cosinus t square minus 4t square sinus t square, and then we multiplied it by, and we are going to multiply it by vy, which is 2t cosinus t square. So if we do this, what are we going to have? Let's multiply. So we have negative 2t sinus t square times negative 2 sinus t square, because we'll use this distributivity, and we'll multiply this by this and multiply this by this. So if I multiply this by this, I'm going to have 4t sinus t square all square. What am I trying to say? That's this negative 2t sinus t square and multiplied by negative 2 sinus t square. And if I do that, I'm going to have 4t, okay, 4t sinus t square, everything square. So I have 4t sinus t square, everything square, because it's sinus t square times sinus t square. Then I do the same thing for the second part. So I'm going to have positive, because negative times negative positive. So I have 8, 4 times 2, 8, t cube, then cosinus t square, sinus t square. So we'll have 8t cube cosinus t square sinus t square. Then we add it to this. So here we have 2t cosinus t square times 2 cosinus t square. That's what? Positive. So it's going to be positive. It's going to be positive 4t cosinus t square, everything square, cosinus t square times cosinus t square. So we have 4t, sorry about that. Okay, all right, so we have 4t cosinus t square, everything square, then multiply this again by this, that's multiplying these two now. So I have negative, remember this is a negative, so we're having negative 8t cube, write that first, negative 8t cube, then sinus t square cosinus t square, sinus t square cosinus t square. Then what else? We can see that this one, they can actually cancel themselves out, because 8t cube cosinus t square sinus t square and negative 8t cube sinus t square cosinus t square. So this can cancel, and we are left with what finally? I use a red pen so we can see that clearly. We are left with 4t sinus t square plus 4t cosinus t square square. And I can remove the 4t, I can factor it out because we have them in both places in the addition. So we'll be left with 4t bracket sinus t square plus cosinus t square. Remember from the beginning, even right from the rappel, that's why I had to highlight this. We are seeing this again for the second time. The first time we saw it was when we were calculating for the modulo of the vector Vitesse, that's the velocity vector, and then now again we are seeing it and trying to find out the uniform auxiliary part. So we can we should maybe write it in a jotter or something where you have this expression in trig and then you get it as 1. It's very important, as we can see where we have to use it. We've used it like twice already. So this we already know is going to give us, I use a blue pen so we see it, give us 1. So what are we left with finally? We're left with 4t, right? And then 4t is greater than 0. For any value of t you put in and it keeps increasing, it's going to be greater than 0. And so we've proven twice using the first method. Is the second method. Our first method, which is here, this, I'll write it here, first method, and then here we calculated is the second method. Either you derive this or you have this, and then you have your answer, and it's greater than 0 on, of course, so it's uniformly more auxiliary. Thank you, and then see you in the next video.